Hey everyone! Today I'm going to be showing you a quick tutorial on how to use the Eclipse Debugger. I'm going to use a Carol program to demonstrate because that's what you're working on right now, but you can use these techniques anytime you work with Eclipse in the future. So, the program we're going to look at today is called Buggy Roomba, which is a different implementation of the Roomba program that you may have tried on your own based on what we saw in lecture. So just to give you an overview of how this works, what Carol will do in this program is it will sweep one row, and then while left is clear, Carol's going to try to move up, and this is when Carol's specifically on the right side or right edge of the world, and then move up, turn around, and do one sweep, and then check if the right is clear, and if so, move up on the left side and do another sweep. And then every time Carol finishes these two sweeps, they check again, should they keep going. And you can see this also using the documentation that the programmer really nicely wrote. It has its little description of the method and then precondition and postcondition. And you should be doing this for every program as a reminder. So what I'm going to do to start is just see, like, does this program work based on a few simple tests. And so because I have a fairly good suspicion that this program works, I'm going to be doing this at a fairly high speed. If you want, you can always use a lower speed when you're debugging and testing to see every step that Carol makes with a little more time. So here we have a pretty good job of creating a world where some rows have like lots of beepers and some rows have only a few. Sometimes there's one in the corner, sometimes there's not. So this is a good testing world. So we're going to start the program, and Carol seems to be doing well. It's cleaning up all the beepers from the rows, and it's turning, and it's checking whether it should keep going, and it keeps going. And in the end, it actually successfully cleans up the whole world. So that's really a good sign for us. But we don't want to test in just one world. We want to test on multiple worlds to make sure that our program works in all situations. So I have another world here, Roomba 2, and this time the number of rows is even. And so we're going to try again, and once again, I have no reason to believe yet that the program doesn't work, so I tested a fairly high speed. I'm going to slow it down just because I know that here there's something weird going on. And whoa, Carol keeps going after cleaning up the final beeper. And so if I increase the speed again, I see that this keeps going, and as we saw in lecture, if you ever enter the same state in a loop that you were before and nothing has changed, that's a sort of indicator that there's an infinite loop going on. So that's not fun. And as I mentioned in this case, I know that the difference between these two worlds is that this one had an even number of rows and the previous one had an odd number. But in general, you'll have to probably do some work to figure out what the difference was between the successful case and the unsuccessful case. And as I mentioned, the high speed was mostly because it's easier to test quickly, and there's less of a barrier to wanting to test if you're going to not have to take too long. So I'm going to stop it using this red box that says, like, what does it say? Terminate, I believe. But so now I want to know what's going on. So what you could do is use a low speed, but also a more sort of methodical way is to use the debugger. So the way you can set a breakpoint is either double click next to the number, next to the line number, or you can right click and say toggle breakpoint. And so if you just run again, it'll do what you want, which is it will run, and then when it hits the breakpoint, it will go into this debugging mode once you interact with this little dialog box. So once again, going to go to this world where we know there's an issue and turn the speed up. And so I'm going to start, and then you get this like dialog box that's kind of scary, but it says, do you want to switch to debug perspective? And the answer is, as far as I can tell, always yes here. So you might as well click the remember my decision, but I'm not going to this time. So now we're in debug perspective, and this little arrow that you can kind of see next to the breakpoint shows that we're on this line of execution, this line of the program, and you can also see it highlighted. So if you move this little box over, we can go line by line seeing what Carol is doing. So the way you can execute just one line is this step over arrow up here. and that just executes whatever that line was. And so we can keep doing this. So we executed the line sweep, which did this whole thing. So Carol didn't just do one motion, did actually several, because it was a whole method that was executed there. And we can keep doing that, and it'll keep doing line by line. And now we're back to this breakpoint. If we don't want to step over again and again, because we want to get up to this spot eventually, or this spot, we can just say resume, which executes code until we get to the breakpoint again. And we can just keep doing that until now we're at a point where like interesting stuff might start to happen soon. So this is where we want to probably restart the just like one line at a time thing. So we moved up to the right, which was good because we still need to do this one last row, and we also want to sweep this row. And what we're hoping here is that this will not make us sweep another row because the right isn't clear. And if you look here, Carol's front is here, which means Carol's right is here. And in fact, Carol doesn't do the stop inside of this if right is clear if statement because you can see that the execution highlighted part moved right back up here instead of doing all the stuff inside of there. So we wanted to stop here, but if you click step over, you see that you go back inside the loop, which means that if while left is clear must not be the right ending condition for this strategy of doing the Roomba. Just as a note, one other thing that we can do if we want to go inside of a method rather than just executing the whole method and trusting that it works is we can use the step into arrow. And so now we step into move upright, and just in general, that's a useful tool if you don't want to trust that a whole method worked. You can see what happened inside that method. Another way, you could also just set a breakpoint and move upright if you wanted to, but that's just a thing you can note. So there are many ways we could fix this problem of Carol not having the right ending condition, but that's not the purpose of this tutorial. We can just see how you were able to figure out what the problem was. So then one other thing I wanted to show you is that we had to do this thing where we just resumed multiple times to hit this breakpoint again and again until we had a good stopping point and when we would start to use step over. Another thing we can do is actually make this breakpoint smarter and have it only execute after it's been hit 5 times. So now let's try this again, and we'll get to the interesting part faster. So Carol sweeping, oops, that's the wrong world. One moment. Sorry, and again, I'm just clicking this fast running person because I've already selected the most recent thing I did was buggy Roomba. So weird message there, that's not important. Gonna go fast. And so we're getting to move upright multiple times, but we finally stop after hitting it 5 times. So that's a cool way to just not have to hit a debug point or a breakpoint over and over again in order to get where you want. And then the final thing, sort of to accomplish a similar point here, is we could, now that we're using variables, again, don't use variables in Carol, that's not allowed, but you know that variables exist. So we can say int I equals 0, this is that declaration initialization we saw, and if we were to set I equal to I plus 1 every time we use the loop, then we can use that as a condition for this breakpoint. So instead of using the hit count, we could use a conditional breakpoint, and the condition here is break if I is greater than or equal to 5. So now we should only hit this breakpoint when I is greater than or equal to 5. I should actually, ooh, that's the wrong spot now. The breakpoint is in the wrong place. So I'm going to delete that and set it here and do the same thing. Nice. All right, and this allows us to see one more cool thing, actually. once we get there. Okay, so we stopped because I is equal to 5. But how do I know that? I can tell because when we're in the debugger mode, we can see all the variables that we're currently using in the program. And so we'll talk about this soon as variables that are currently in scope. But we see this L for local variable I, again, local, we'll talk about soon, I is equal to 5. And so if we were to just step, oops, and now in that last line, I changed to 6, so it's highlighted. And so this is a useful tool for later programs where you're using variables and watching how they change. So that's pretty much all you'll need to know for using the debugger. One helpful thing is that if you go inside of a method and you accidentally go inside some method that you didn't write, let's show an example of that. So we're going step into, and then we step into turn left. Now we're in this like weird file carol.class that you didn't write. You can step return and then just move on and get out of that weirdness. And then finally, this again lets you stop. And if you want to return out of this debugger view, you just click Java, and now you have what you had before. So I hope that's helpful in getting you to use the debugger. I think one of the really interesting, or sorry, not interesting, but instructive marks of a good programmer is that they will use the debugger as opposed to just like trying to read code and seeing what's happening rather than methodically finding bugs. So I encourage you to use the debugger on both Carol and all your other assignments, and best of luck with assignment 1.